This is Ashiqur Rahman Imran, and now I'm with you with reactive extension. So this is the very first tutorial, and this is introduction of reactive extension. So what is actually reactive extension? So in software programming, reactive extension, also known as ReactiveX. Reactive extension provide to operate on sequence of data regardless of whether the data is synchronous or asynchronous. So what it provide actually? So it operates on sequence of data regardless of the data is synchronous or asynchronous, and a set of sequence operator operate on each item in a sequence. So each operator operate with a sequence. Reactive extension is an API for asynchronous programming with observable stream. Asynchronous programming allows programmers to call function and then have the function callback when they are done, usually by giving the function the address of another function to execute when it is done. Programs designed in this way often avoid overhead of having many threads constantly starting and stopping. Observable stream in the context of reactive extension are like event emitters that emits three events: next, error, and complete. An observable emits next event until it either emits an error event or complete event. So when we are performing any event, if the event has an error or the event has finished, then the next event call automatically. However, at that point it will not emit any more event unless it is subscribed to again. So without subscription again, it will not emit. And there are some key points in reactive extension. These are observable, operators, single, subject, scheduler. And the very first I'm describing observable. In reactive extension, an observer subscribes to an observable. So when we are using reactive extension, an observer first it have to subscribe to an observable. Then that observer reacts to whether items or sequence of items the observable emits. This pattern facilitates concurrent operation because it doesn't need to block while waiting for the observable to emit objects, but instead it creates a sentry in the form of an observer that stands ready to react appropriately at whatever future time the observable does so. So when we need to establish any observer, we need these things: on next, on completed, and on error. So why we need this? When the operation is complete, what is on next? If it has any error, what is on next? So call a method, store the return value from the method in a variable. So when we are calling a method, we have to store the return value from that method in a variable, and we have to use that variable, and we have to use this new value, which value is useful. And this is the diagram of observable. So very first, this is the observable queue. So there are 6 items, emitted items to observable. So this is the observable queue, and these items are already emitted here. So in the last, this is the 5th queue, and the very first, this item is already finished. So transformation of observable. So it is transforming to another state, and after that the item will transform to observable result. Or if we have any error, then what it will do? Any reason observable terminated automatically. So the observable will terminate if any reason or any kind of error happen here. So this is the process how observable work, and we have operator here. An operator is a function that takes one observable as its first argument and returns another observable. So when we are using any operator, then we pass our first argument and we return another observable. Then for every item that the source observable emits, it will apply a function to that item and then emit it on the destination observable. It can even emit another observable on the destination observable. This is called an inner observable. There are many types of operator. These are so creating observable, transforming observable. So when we are creating anything, then we can use this, and we need to transform our observable to one state to another. Then we need to filter, error handling, observable utility operator, conditional and boolean operator, mathematical aggregate operators, backpressure operators, operators to convert observable. So these are the operators. So in next we have single. What is single actually? Single is something like an observable, but instead of emitting a series of values anywhere from none at all to an infinite number, it always either emits one value or an error as notification. So when we are using single, it will return only one single value, or if is there any problem or is there any error, then it will return error. So it has to function on success. A single passes. This method the sole item that the single emits. On error, a single passes. This method the throwable that caused the single to be unable to emit an item. Note, this is a very important thing. A single will call only one of this method and will only call it once. So it cannot call multiple times upon calling either method. A single terminates and the subscription to it end. So when we're ending any subscription, then we need to call the single. And subject, this is the most important thing here. So a subject is a sort of bridge or proxy which acts both as an observer and as an observable. So it is working as an observer or as an observable. Because it is an observer, it can subscribe to one or more observable. So a subject can subscribe one or more observable here, and because it is an observable, it can pass through the items to its observers by remitting them, and it can also emit new items. Because a subject subscribes to an observable, it will trigger that observable to begin emitting items. This can have the effects of making the resulting subject a hot observable variant of the original cold observable. There are four types of subject. These are async subject. So we have async subject, and next we have behavior subject, publish subject, and replay subject. Each subject have different working policy. So in next we'll learn that. Scheduler. This is the most important thing here. If you want to introduce multi-threading into your cascade of observable operators, so we have so many operators. If we want to introduce multi-threading here, you can do so by instructing this operator to operate on particular scheduler. Some reactive extension observable operators that have variant that take a scheduler as a parameter. So this instruct the operators to do some or all of its works on a particular scheduler. By default, an observable and the chain of operator that you apply to it will do its work and will notify its observer on the same thread on which its subscribe method is called. The subscribe on operator changes this behavior by specifying a different scheduler on which observable should operate. The observer on operate specifies a different scheduler that the observable will use to send notification to its observer. So that is actual scheduler. So reactive extension is a very good thing, but where to use? So we don't need to use it in every application or every web application. So there are certain rules and when we need to use these things. So handling real-time data, dealing with sequence of event. So maybe we have an application and in that application we have to handle sequence of event. So on that time we can use it. Infrastructure events like from file watcher system or WMI events and broadcast message through WebSocket. So broadcast message such as like chatting, notification, these are the things. And level of concurrency control. So actually reactive extension provide level of concurrency control, which is very important thing. And on that time we can use reactive extension. Thank you everyone and stay connected and get latest update every day.